We've been adding wires and connectors to this to get the insides wired up. And so I'm going to show you up close. Boop. Okay, so there you can kind of see that there are 10 fluorescent tubes in here, and all the connectors and all the wires are now mounted on both ends. But the wires aren't connected to anything. So we're going to go ahead and connect up those wires tonight. And this will be the last major issue. Now if you look, you'll see we've got one tube in here that's lit. And that's what it looks like. That's what we're trying to get to. And it's using one ballast connection. So I'm going to unplug the unit right now. And we'll begin by connecting all of the ballasts together. Now I need a volunteer. Evan, you just volunteered. Come on up. Don't you love it? No, just. Okay, so have you ever used these guys before? Yeah, cool. So what I'm going to ask you to do is we're going to use a group of switches that we installed here to control the different banks of lights. In order to do that, we're going to take the black wires and we're going to connect them in groups to the switches. The white wires are the ground, and all the white wires are going to go together in one bundle. So what I'm going to have you do is gather all the white wires from the ballast together into one knot and take the white wire here and subdue them with one of these. Okay? So I'll let you go ahead and pull all the rest of the white wires together and get working on that piece.
Carl, is that yellow thing just a plastic cap that screws down over the wires?
That is correct. It is a twist cap, and got a good bundle there. It feels like we got a good nice tight grip on that. Whoa, that one got away from us. Gonna ask you to go back and try to get him. Maybe what you want to do is strip off a little bit more wire. Here, let me get wire stripper here. Looks like we don't have quite enough wire to work with. So there, that will give you enough. So twist that up into a piece of wire. And Lynn, I'm going to have you follow us up close on the camera. Okay, you think you got a good better bite? Nope, we got one that's jumping out here. Let me hang on to this for a second, okay? Let's see what we got here. Okay, I think we're going to come back and redress those wires. They don't seem to be behaving right. So let's try. Let me get them. There should be 5 ballasts, so there will be 5 total conductors. That's the 110. Okay. Okay. So 2. This one wants to argue a little bit. Okay, so 3. Four. 5. Okay, so let's see what you got here. Let me just take them all. The first thing we gotta do is make sure they're all the same length so that they all start at the same point. Okay. So is that a big enough cap? Yeah, it looks like it. Okay. It looks like that time we got it. Okay. Now to make this a little bit more stable, we've got 3 switches. And we know these 3 switches are going to turn on the black lead to 3 different banks of lights. So I've split one of these. I'd like you to come around here and split using the scissors the other 2. And then we're going to pull them apart a fair distance, because those wires are actually going to wind up going different places. That's fine, right there. Yeah, so about yay. And what happens is, if we take one wire from each of these switches, doesn't matter which one, I'm going to strip them. So you got a fairly long chunk of wire there. You to go ahead and strip the other 2. In fact, why don't you go ahead and strip the other 5? All to about the same length. Now let's talk about what we want in order for this to work. We want a single switch to control 2 lamps. A next switch controls 4 lamps. And the next switch controls 4 lamps. So I can turn on 2 lamps, I can turn on 4 lamps, I can turn on 6 lamps, I can turn on 8 lamps, or I can turn on 10 lamps with just 3 switches. And the way I do that is by grouping them into 2, 4, and 4. Think you got them all done? Okay, so your next challenge is going to be take one wire from each of those switches and get the black one. So we got 5. So the ballasts each control 2 lamps. So we have a total of 5 ballasts that have to be powered by these 3 switches. So one switch will have 1 ballast on it, and the other 2 switches will have 2 ballasts on them. So take ideally, because there's only 5, we'll take 2 together and one of these, and we'll go ahead and we'll twist them together. And then do the same thing with 2 more ballasts. And then take the last wire and connect it to just 1 ballast. Okay? And I'll give you the wire nuts. So there's 3 wire nuts. Now the ballast on this guy has a black wire and a white wire, and they are the 110 volt from the line cord, and the ballast is really a form of power supply for the lamps. Think of it that way. And so we're doing the circuitry on the 110 volt side. Now we get out on the lamp side, and instead of having black and white wires, we've got blue and red wires. And so we've done some connectors here on the lamp side. We're going to cut those off because we're going to group them together. Instead of just doing one lamp, we're going to do groups of 4.
Just want to make sure, Carl. So it's one of these for 2 of the ballasts, or one ballast for...
One ballast will have 1 wire, so we'll have one that's just a 1-on-1, okay? The other 2 switches will each have 2 ballasts connected to them. All right, so that, so you're going to find 2 wires. You got a black wire here, and you got a black wire here. Those 2 together go with that black wire there, and you're going to group them together. Now the purpose of a prototype is to illustrate the principle and find any bugs in the design phase and identify them and correct them. This device on paper will produce about 150 watts of UVC light. With that amount of light, we can run air through this tube at a rate of 1,500 cubic feet a minute, and it will sterilize that air so thoroughly that COVID will not be able to survive the journey through that tube. That's what we want. So there are a number of different ways in which we have to test that. We have a UVC meter once the machine is operational, and we'll check the light output to make sure it's what we expect. And then when the light is matching what the drawings say, and we've successfully run air through it, and over a period of time watch the output of the lamps to make sure they don't cool down or something doesn't vibrate loose, because the air going through here is going to be going through here fast. It's going to be probably 50-60 mile an hour wind, and the mechanical strength of the clips that are holding the lamps and the connectors and whatever have to be capable of doing the job. So The only way you find that out is by turning it on and see what flies out of it. Fluorescent lights also have a unique design aspect when they're hooked up on these kinds of ballasts. Both ends of the fluorescent tube have what is called a filament that stretches between two pins. However, the design of the fluorescent lamp is such that only one filament winds up receiving voltage. The other one is actually shorted out. So we have a hot end and a cold end. Okay, so what do we got? We got a group of 2 and we've got a group of 1. So we should be looking for one more ballast wire. Somewhere. There you go. Working in these marshmallow suits is not as easy as it looks. Okay, so now we've got 2 ballasts connected up, 2 ballasts connected up, 1 ballast connected up. What do you suppose we do with the other side of these 3 wires? Where do you think this one goes? Okay, well, it actually goes back to the black wire on our power plug. So if you'll go ahead and, here, let me get you another wire nut. Oop. Got one on the floor? Yeah, we do. Okay, now this is a bird's nest, but when you're prototyping, before you get everything all tucked away, you want to test and make sure you know what works and what doesn't. So initially, we put this thing together in a bird's nest configuration so we can follow the wires wherever they go. So if there's a problem, we can get to it. Are we ready to plug this in yet, do you think? No, and he's right, we're not. Why aren't we? Well, because all of the other wires that come out of the ballast aren't connected yet. So all of the wiring on the lamp side has yet to be done. So we're going to get started on the lamp side wiring. Now, the way this works is each ballast has 2 blue wires and 1 orange wire. And the orange wire, if you can imagine this, each connector on a bulb has a wire connected to it, so you see these wires coming out by 2s. And there's a filament that each one of these 2 wires connects to. However, on the orange side of the connector, we actually take those two wires and short them together and tie them off to one orange wire. That's the cold side of the bulb. We do something different on the hot side, which is where the two blue wires are, which power our filter. So we know that we're going to, for each ballast, we're going to light 2 lamps. So I'm going to take 2 lamps and 2 lamps, or 2 sets of 2 wires, or 4 wires total, which covers 2 lamps, and connect 1 orange wire to it. And we will do that with each one of the 4 ballasts. Okay? The trick is that as you're doing this, if I'm using this, say these 2 lights right here, and I'm connecting this ballast, I have to make sure that the other end of the ballast, those 2 wires, go to the same 2 corresponding bulbs. So we do have to keep things straight. Okay, so the first challenge here, and I'm looking at these, and I'm going to ask you, we're going to see if we can shorten this up. Where's the... Can I have you hold this for a sec? We're going to take... I'm looking at the length of these wires, and they're less than half an inch, and we just can't use these wire nuts on anything that short. So we're going to cut them off. And I've adjusted the wiring stripper so we get a longer wire. Okay? So notice I'm putting the wire in, and I'm putting it all the way out to the end of that black thing there, and then I'm getting a good grip on it with my thumb and putting my thumb up against that block, and it just comes right off. Okay? So I want you to go ahead and trim and clip these wires all the way around this end of the tube. There's a trimmer here. You get started on that side. I'm going to take a trimmer on this side, and I'm just going to start around in the circle. We'll put some fresh lead length on here because we're going to need it. Can anyone suggest to me, since we're now shipping all this vaccine, why this device might continue to be useful?
It could be useful in hospitals if you consider that there's lots of contagious diseases there. And if you want to protect the healthcare workers and other patients, then this doesn't only apply to like COVID. A lot of viruses and bacteria can be killed or eliminated through UV light, UVC.
Absolutely, you're spot on. This system is a far more has far more efficacy than just COVID. And yeah, you're absolutely spot on. And it's the cost. The reason that this particular version may wind up being so valuable is because it's put together with materials that you can get from Ace Hardware and Amazon. I mean, nothing here is rocket science. And we have, using innovation, leveraged some cheaper materials than some of the systems that are designed to do this same work in Europe, and they cost literally tens of thousands of dollars. We're looking at something that you can build for well under $10,000, well under $1,000. And indeed, if you put a set of instructions out on YouTube, people could build these things cheaply and effectively and use them in a variety of settings. Any place where you're dealing with a biological threat is a good example.
Also, the question of how long before the next epidemic or pandemic?
Yeah, and what if one of these variants hops the fence and we discover that we have to back up and make another vaccine? We don't have a year to do that.
Right.
And as long as the herd immunity is not there, there is a risk that the virus could evolve and jump the fence. And the fence is the effectivity of the vaccines. Okay. How are we doing on time?
35 minutes to go.
Okay. I'm going to get some different wire nuts for this part of the project. Oh, got stuck? I'll help you in just a sec. Can I get you to hold these? Yeah, that first time that did that to me, that kind of caught me by surprise too. I think there's a screw back here that's coming loose, but there you go.
Can you reset the distance too for this? Like how far you want it?
Oh God. About there.
Also, how do you want to coordinate for the wires?
Well, my idea would be take a look and see which ballast I'm going for, and the two bulbs that I'm using are on those two screws. So those two screws would come off of the orange wire, which is this guy, on that side. So all four of those wires and that one okay. So I've got 1, 2.
I need some of those too.
Now in this example on my end, you'll notice I got 2 wires powering 2 bulbs. One wire goes to each of the individual leads. All you have to know is that all 4 wires connect to that same wire coming out of that same ballast. If we follow that same pattern all the way around, it'll automatically line up.
What about for the one ballast that's only connected to one switch?
Okay, the one balanced will still tie off to 2 bulbs. And you won't be able to do, you're still going to do one. In each case, we've done one ballast for 2 bulbs. And that remains consistent all the way around. So obviously one of those ballasts will only turn on 2 bulbs, where the other groupings will turn on more. Okay. So you've got a group of 4 coming off of the same ballast. You're doing that group of 4 off of, should be this guy. Beautiful. Yeah, we're going to cut him out. We just he was just a prototype we wanted to see, make sure we understood how those work. So okay, and okay. Got a group of 4. Group of 4. So we're ready for the next group. Okay, so I'm going to rotate this. This would be the next ballast. Time check.
About 25 minutes.
Okay. Ready to go some more? Okay. these two. You're beating me over there, aren't you? Good work. Good stuff. I love it.
Mine's easier than yours, so.
Okay. Have you got your end wired?
Which one? Or just.
Oh, are you finished yet?
Yeah.
Oh, you are. Okay. Let's see.
This one.
Are you sure that they all go to the same bulbs that...
I did just, yeah, I just did going
Good.
counterclockwise 2 for each of them.
Good. Thank you. Okay. All right, coming down the home stretch here. Okay. So our bird nest looks like it's all put together. Okay. Now look down the end of yours and make sure that all the little wires are still on their clips. And that in the course of doing that, we haven't pulled any free.
Looks good.
Yeah, it looks good on this end. I'm not seeing anything loose. Okay. Okay, now we do the fire in the hole thing. Gonna find out if it works. We'll begin by making sure that all the switches are off. So theoretically, nothing should happen when I plug it in. Theoretically. Okay, well that theory worked. Okay, now, looking at our wiring combination, let's see if we can figure out which one is a 4-banger and which one is a... We've got 1 and 2 and 2. So this is our 1 guy. So this should light up 2 bulbs, theoretically. Ready?
I see 1 bulb.
1 bulb.
Yes.
Okay. So let's start with where that goes.
It was I
Okay.
think it was this one.
We're going to have to do some repair here because our ballast got away from us. That was unfortunate. Okay, let me I'm going to do a emergency wrap around here just to add a stretch of tape. Okay, we got one ballast still completely off.
You want me to hold the way you tape it?
Now I'm just going to go around. Can you hold him up? Yeah. Okay. That takes care of that side. Okay. Do more wrap around this side and we'll be good. Okay, can you go ahead and hold him up? Somehow or other. Go around. Can you go ahead and pull him through? And then come up that side. Okay. Thing is, we've got to go over each one of these.
Okay.
Okay. That'll hold it on till we're done testing. All right, let's go back to our question. Starting with which one? Still got one bulb? Okay. So let's follow the wires out. This is the ballast in concern. So, which two bulbs are you looking at?
These two.
Okay, you got those two. Let me... Let's rotate. So the other two wires have to be going to those four.
Do you want to turn it on again to see which bulb is it turning on? Okay, it's this one.
Okay, I see. The one that's not turning on. Interesting. Okay, I'm going to go to a bank of four. That's strange. Let's go to another one. Okay, clearly we've got something strange going on here. That should be all of them, and it looks like it's every other one. Okay. So coming back to this one ballast,
It's the right screws.
yeah, those two screws, these two right here, yeah, and you got all four tied off down there.
Yep.
Okay. Oh, I see the problem. I see the problem. Okay, it is a wiring problem at my end. I've got to swap. I'll swap one of these. We'll see if it fixes it. Time check.
About 6 minutes remaining.
Okay. Okay, ready to check?
Yep, 2 bulbs.
Okay, so I know what the problem is. It's just a matter of going backing around now and changing that wiring configuration for the other groups. So, our experiment has worked. We've got light in the tube, probably another 15 minutes of wiring, and the prototype will be ready. So next week, we'll actually have the blower set up, and we'll actually begin doing some light intensity testing and looking at the total package. Good stuff. Okay, we're gonna start the checkout. Thank you all for watching.
Come on.